Today we're checking out Stepfun AI. This company is called Stepfun and they've released Stepfun 3.5-Flash. And this is a super fast model that is 196 billion parameters. So it's really, really deep, but it only has 11 billion active parameters, which means it's really, really fast. We're talking about mini max speeds, super fast like that. We're going to be testing it out. We're going to be doing agentic stuff. We're going to be jumping back into OpenClaw, seeing how awful it is or great it is at it. Maybe it's going to be great. I haven't tested it out myself. Let's find out. We're also going to be doing some coding tests. I've already done some coding tests. I'll show you the results. I'll also give you a little introduction to who Stepfun are, because they are actually one of the 6 tigers of China. Now, China has the best models that are open weight. We're talking about Kimi K 2.5. We're talking about ZAI, talking about Minimax, we're talking about all the 6 tigers, and Stepfun is up there, and they've got foundation models of video, audio, and multimodal. But interesting thing about it is that it was actually founded by a former senior vice president of the people who are funding the whole AI business. Who are the people that invested into OpenAI to get it going? Microsoft. Who are investing in Claude, who are investing everywhere, left, right, and center, who just lost 100 billion off their share price? Microsoft. So all the best people, the talent from that company is just going viral into the world and starting the show. So it sounds like a fun name. I thought it was just a bunch of kids that made this when I heard the name. Apparently, they're one of the biggest AI companies in China. So it's going to be a great model. And just look at the benchmarks over here. It is like showing intelligence that, well, they're saying they're better than ZAI. They're talking about they're better than GLM 4.7. That's what they're saying here in this stat. Just below, they're saying they beat Kimi K 2.5. Is that real? I don't believe it. Over here with software engineering that people love on this channel, it is beating GLM, but it's just below Kimi K 2.5. But generally it is up there. And this is a model that can fit. You don't need the 512 gigs Max Studio or 2 of them. You can fit it into a 256 or less. And I've got the 6-bit quant uploading away over here, and it's only using my test 150 gibs of memory. So let's just jump in and just see how it's performing. I've got a Q6 version. I'm gonna go with the prompt, write a story. I've limited it to 1,000 tokens that we can get from our token speed. And you see right there, look at that, 43 tokens a second, just bombing it away. So it should be really, really fast for agent kind of tasks, because it's just going to be coding like crazy. And if it's as smart as GLM 4.7, then we're going to be in a treat. So we just ran this test, ended up with 43 tokens a second, and we used up 149 gibs of memory. So that is all standard stuff. Let's show you some of the results I did in the background here. So this is a 3D universe demonstration. This is with thinking disabled. You can click on the planets to see what's going on. It's not the best version, but it's pretty much up there, because some versions look like this and they've got extra features on top of this, but they mess up the lighting, whereas this one's got the lighting and it's got so much potential. Unfortunately, when I enabled thinking, the result wasn't as good, and I like that, because one of the things I don't like is thinking models, because they just slow everything down. I do like that this model, you can toll the thinking, and so I'm guessing for puzzles and complicated scenarios, then you want to enable thinking, get smarter answers. We'll test it out. But when it comes to pure coding, it looks like the non-thinking version is producing better results. So we've got 3D Flappy Birds over here. It's a very, very hard game. I can't even get to the pipes. Again, it's not the worst version. So this is a good quality quant, 6.5. We get good perplexity in our results. So over here, 6.5, you normally get 96.9% token accuracy. The full unquantized version, which runs at half the speed at 25 tokens a second and uses double the memory. So the thinking version of Flappy Birds, it looks gorgeous, but unfortunately it doesn't float. So again, thinking makes the coding slightly worse. With Microsoft Word, again, this looks decent, looks very, very Word-esque. Can you change the font? Unfortunately, you can't change the font. Can you change the font size? You can't. Yeah, it's not the best version of Word that's out there, because it's actually got a runtime error. So probably if I feed it that error, it'll probably fix up the code and get it going again and get it working. The thinking version of Word, let's just see, it also has the same runtime error. So thinking and non-thinking, that one failed. This is a 6-bit quant. We could potentially run the unquantized version, but generally at 6.5, you shouldn't be making these errors. So, you know, it's not, again, the best model, but it's probably the best model that has this memory footprint and speed. So let's jump in and ask it some questions. We'll start off and do the logical puzzles. So I got thinking disabled, and surgeon is the boy's father, and They say the surgeon is the boy's mother. This is with thinking disabled. And it's with thinking disabled, it's going on a little bit of a rambit, trying to figure out. So let's just see the touch points. So first, it was 100% certain it was the mother. And then with father, it was also 100% there. 77% certain it was the mother on the second time round. And by the end of it, it just settled down and said it was going to be the mother. And father was a very, very 0.706% chance of picking out father. What I'll do actually is let's just make it say father. It was a 0.1% chance of saying it. If I force it to say father, it goes ahead and it even corrects itself and forces the answer back to mother. So this one is highly trained on the data sets that have the riddles by purity. And with non-thinking enabled, it doesn't have that chain of thought to correct itself to realize that is the boy's father. What I'll do, I'll run this test one more time and I'll have thinking enabled. It's now discussing the scenario, so it might get a better result. Let's see what's going to happen here. Thus, answer father. So with thinking enabled, it seems to have been just in a loop now saying it's a surgeon is the father. So it's got the right answer, but it's stuck in a loop. So that's a kind of a negative. So definitely there is potential when you add in the father. What I'll do now is I'll add in the second logical puzzle I like to run, and it's to do with runaway trolley. This one is the bodies on the track are already dead. So normal one is considering 5 lives versus 1 life. Whereas this one, if you pull the lever, you're actually going to take out a real person. So here it says not pulling the lever results in no additional harm. Pulling the lever actively causes death. Therefore, you should not pull the lever. So with thinking enabled, it is definitely smart. And what's good about this one is it did actually break out that thinking chain on its own. So yeah, just a little bit of bugs maybe to fix, probably on the inferencing side, or I'll just make that breaking out of the loops because it seems to be common with several models. For example, GLM 4.7-Flash also suffers from just looping reasoning. So that's just something to think. But definitely with thinking enabled, it is got smart answers. How smart is that code? I'm going to give it the regex one that most models seem to not be able to answer. And you know what I'll actually do is for this test, I'm going to jump in on the server and I'm going to enable a feature called batching, which allows you to run multiple inferences at the same time. You can pretty much double your total throughput. So I got running here at the same time. Now it was going around 40 tokens plus a second when it was just one inference. With 2, we're going around 30 tokens a second each. So we've gone from 40 tokens a second to 60 tokens a second total throughput with them running at the same time. And I've got it on the left side. It's got thinking disabled, and on the right side we've got thinking enabled. The answer we're looking to get is a modification of KM0 because we want to make _1 detected. Interestingly enough, even though I have thinking disabled on the left, it seems to be going through some sort of reasoning pathway. So it's got a corrected approach there. I can see here it's got a \D, so it's going to allow digits or A to Z. So if it does actually pick up this answer, this would be the correct one, and that's with thinking disabled. Now the question is, how many tokens does it need to actually get the answer? So getting the right answer to this ranges from about 8,000 tokens to, I think the smallest one was Kimi K2.5. That one did it in a low amount. But for example, its competition, GLM 4.7, that one took 6,700 tokens. So will it be less than that? So we do have an answer with the non-thinking version. It took 4,300 tokens at 30 tokens a second. That's just one of the instances. We will still run the other one at 30 tokens a second. Right now it's going back up to 37. So the answer it presented is digits and AZ. So this is actually the right answer. That's good. Very, very impressive. I'm happy with that. And we're thinking we're over 7,000 tokens now. I can see that it's definitely playing with all the different possibilities as in KM, KM, 01. So it definitely knows that it's the _1 is the problem. So I think it's going to get the right answer. So I'm just going to go to the next challenge here. And this one is kind of like a coding riddle for Swift. And ChatGPT failed at getting the right answer. Claude failed at getting the right answer. So ChatGPT is saying that I need to add multi-line text alignment leading again. That's wrong. Nah, Claude, it's going to give me like 2 different solutions. And as you can see, they're both wrong. Look, new line, wrong, wrong, wrong. The only models that have actually gotten the right answer is Gemini. Some people found that out. And Kimi K2.5 actually got it right when you either have it online with the agent version or you increase the number of experts sent to a token. So there's a button here called mixture of experts. And by default, this model sends 8 experts per token. So you can like double it and make it deeper. When we made Kimi K2.5 super deep, added in all the tokens, he actually got the right answer. That was good. For this one, I'm going to go with thinking and non-thinking. And the riddle here is I'm asking why the text isn't taking up the full width. And the reason why is because I have new lines in the actual text. So most models I've tested this with, like 99% of them, they just miss that. They just jump in, try and find a different answer. Here, we got a solution already. It's got add a spacer. It's good that it's giving you multiple solutions. It's giving you kind of like ideas to try things out. Although sometimes it does get confusing when it gives you too many solutions. I'm like, which one is the best one? So max width, that's wrong. Spacer, that's wrong. Layout priority, that's wrong. So these are the typical answers you do get. So it's coming up with an answer, very, very similar answers that it had with thinking is disabled. H-stack expand, that's wrong. Layout priority, that's wrong. I do like the speed of this. Look at that, almost 40 tokens a second, and we're at 4,000 tokens. It's very, very fast. And solution one is the best. So it actually got the wrong answer. One more test I want to see is how good is it at creative writing. So I'm going to say, write a story about discovering the atom. The story begins not in a laboratory. The story begins not in a laboratory, but in a dusty, sun-drenched study in ancient Greece. It's writing something, it's not crazy, and Schrodinger's is writing some stuff. Now, it did only output 1,000 tokens, so that is not that much. So I've seen models that can write 4,000 plus just on a basic prompt like this. So maybe it's not your best creative writing buddy, but at that speed, you can probably give it a system prompt and make it work that way. Now, let's see how it handles tool calls. So I'll just quickly so I'm going to go into Wikipedia. In July 2024, Stepfun officially launched Step 2, enable tool calls here. And I've got a tool that allows it to get any web page content, and it just runs a bit of Python code. And these tool calls are all customizable. You can write your own. You can use a DuckDuckGo search, all these kind of stuff. But regardless, I'm going to say, go to Wikipedia's. So this one should have to go to Wikipedia, paginate it to find the right section and tell me the response it gives it. It's making a web request right now. Got the web request result, processing the 2,000 tokens it got back. And I think it actually got the full page here, all 7,000 worth. So it should actually know something that's funny here. It says July 202-2. So unfortunately here, look at that. It's gone into a loop. So probably on the positives, it managed to get the article back from Wikipedia, but there seems to be that bug with the looping. What I'll do instead now is actually just raise the temperature. I'll make it maybe 0.1 is just too aggressive. So I'll make it 1. So it's more creative this time around. Okay. So it says Step 2 was announced in February 2025. It is unfortunately still looping with that temperature. So something needs to get fixed. I'll work on that and report on it soon. And no, that's even wrong. July 2024. That was a little taster of the tool calls. Let's just see how it does now with the clear. So I'm firing up my virtual machines in parallels. What's actually interesting, and a lot of you guys actually missed this, my virtual machine is Mac OS 26.2, and I'm actually using Mac OS 15. So I'm virtualizing the next version of the operating system from my operating system. That's kind of cool. So we're back in OpenClaw here to change the model. It's a very, very young application. So you got to like work with what you got. You go into config, form, raw. Previously, we set it up with Kimi K 2.5. Check out the previous video for that. So I'm just going to reuse that bit of code. And I've pointed it over to my Mac Studio directly this time around. And instead of using Moonshot Kimi K 2.5 as the model ID, I'm going to go into server, click on my server over here, and find my model, which is this one here, Stepfun AI Step-3.5-Flash Q. And I'll paste that, and I'll also paste it to replace this ID. Just notice there is 2 forward slashes here because the model ID actually has a forward slash at the beginning. So you have to respect that. You hit save, and that is it. We're now pointing to the new model. So I'm going to say new session. And over in my Mac Studio, we can see that we're generating a new session right now. The first time it generates a new session takes a little while, and this little while is a lot faster than most models because it's running at almost 45 tokens a second. So once that's done, it's going to start replying back in my virtual machine. I've learned matchings, where you've been, open clarity, the user's not done, it's asked me first. So I don't know what happened there is. I'm going to just say hello to see if it's even conscionable. Okay, it seems to be printing out nonsense for some reason. So on the positives, we can see that it is connecting correctly to Inferencer, and the Inferencer is giving it back responses, but for some reason the responses seems to be just like random stuff. So maybe the system prompt that OpenClaw is giving it is just too complicated for this model to comprehend. I mean, we got it running fast at least, so that's pretty good. And there is actual serious potential with this model. As you can see from these demonstrations, look at that 3D solar system over here. and even Flappy Birds had a demonstration. So there's potential there. And it did get the regex question correct. And it also did the trolley, runaway trolley. If it was on the control tower, we're lucky to have it on the control tower, because some models say, yes, let's run down these people. So that is kind of good that it's running. So what do you guys think of Stepfun's Step 3.5, one of the 6 tigers of Sheena? And benchmarks wise, it seems to be very, very good. And there's lots of potential in there, especially the raw performance and speed and even memory footprint. We ran that batching scenario with 6 batches plus. We got over 80 tokens a second, and I'm on Mac Studio, but we didn't have any memory issues. So that's very, very lovely. Let me know what you guys think. Hope you guys found this video useful and enjoyed the show.